Hi, in today's video, we shall go through how to use R for a simple linear regression model between a quantitative variable and a categorical variable. Simply put, linear regression is used to create a best estimated linear relationship model between a quantitative variable against either another quantitative or categorical dataset. Simple linear regression deals with two variables only, while multiple linear regression deals with multiple variables. We shall now go through a simple linear regression model between a quantitative variable, the selling price of cars, and a categorical variable, which is the type of fuel they use. We assume that the data has been imported by your own methods and shall now move on to the more technical part of the code. Before starting, we need to understand that R will know how to deal with the categorical variable by making it into an indicator random variable. This means that for each category, the value of the variable is equal to 1 when it occurs and 0 when it does not. More of this will be explained later in the video. So we will now use the factor function to tell R what is our categorical variable. After that, we shall use the summary function to see what are the number of groups and levels that there is, and if needed to, use the if-else statement to group the necessary groups into one. As you can see from my example, there are different fuel types, but majority of them are in the diesel and petrol categories. Hence, we can use the if-else statement to regroup the categorical variable into two groups, diesel and other type of petrol use. After that, all we need is to then use the linear model function, which is lm bracket selling price, which is the dependent variable, tilde, which means against, the type of fuel, which is the independent variable, also known as the regressor. Then we shall use the summary function to view the estimated coefficients of the linear model, and it also provides us with other information that I'll go through. After using the summary function, we can see that the y-intercept is 669094 and the coefficient of the indicator variable when few equals to others is negative 327369. Thus, we can now determine that the best estimated linear model between the two datasets is that the selling price of the car equals to 669094 minus 327369 times the indicator random variable, which in our case is when if the fuel type is others, it equals to 1, and when it's not, it equals to 0. Because all of the coefficients have a p-value of less than 0.01 and the overall p-value is also less than 0.01, we have strong evidence to suggest that the linear model is significant and able to estimate a linear relationship between the two datasets. Unlike the linear regression model for quantitative variable, we do not need to use the predict function in this R, as the categorical data does not have a meaningful numerical value to be used in the prediction. But we can still interpret the coefficient, which means that when the fuel is other types, not diesel, the price of the car is nearly 33,000 less than when the car uses diesel. You can see by taking the coefficient multiplied by 1, since the indicator random variable is 1 when the fuel is others and 0 when it's not. I've now come to the end of the video of how to use R to get a simple linear regression between a quantitative variable and a categorical variable, and I hoped you have enjoyed it. Feel free to like, share and subscribe, and comment any other pointers that I've missed out and can address in the comment sections down below. Thank you.